So now we're going to write exponential functions, either given a graph or given a table to them. And we're only going to do this for functions that have an asymptote of 0. So the first thing that we're going to want to check for any of these graphs or any of the tables is to see if the asymptote is 0. If the asymptote isn't 0, then we're just going to write asymptote not 0, and we're not going to actually write a function for it. We're only going to be writing functions for asymptotes of 0. So the first thing we want to do, check to make sure the asymptote is 0. After we look to make sure the asymptote is 0, then we want to just kind of peruse the graph or the table and decide if it's exponential growth or if it's exponential decay, because that's going to help us make sure that we're picking out the right growth factor. Because remember, if it's exponential growth, that means the values are getting bigger, and that means that my growth factor has to be bigger than 1. If it's decay, the values are getting smaller, and my growth factor has to be less than 1. So just to give ourselves kind of an idea before we start, we want to decide if we have exponential growth which means the values are getting bigger, or decay, where the values are getting smaller. Your classwork isn't going to actually ask you to identify growth or decay, but your homework will physically ask you to put that in just to make sure that you are checking it and that you totally understand which one growth and which one decay is. So after we decide that, then we want to pick out our initial value, which is in this situation, since our asymptotes are going to be 0, our initial value and our y-intercept will always be the same. So 3, pick out initial value, which is the same as the y-intercept, since asymptote equals 0. And then the last thing we want to do is figure out our growth factor. So figure out what we're either multiplying by or dividing by to get each value. Find our growth factor. And there's different ways that we can find our growth factor. Sometimes you might be able to just look at the table and you're going to recognize, oh, these are all being multiplied by 2. Or, oh, these are all being divided by 3. You'll be able to pick it out really fast. If you weren't sure, you could always take 2 y values, take the bigger y value, the farther along y value, and divide it by the y value that shows up first. And I'll show you how to do this. So once we have our initial value and our growth factor, then we can just plug them into our equation, and we're good to go. So the first one we're going to look at are graphs. So if we want to write equations for graphs, I'll make this bigger so you can see it. We want to write an equation for this graph. So we need to first decide, is the asymptote 0? And it does appear to be that way. It's kind of flattening out right at 0. Then we want to say, okay, is this growth or decay? If we look at it, it's starting up high and it's slowly getting lower, right? So that means that we're talking about decay here. So we know this is decay, which does mean that our growth factor, we should be dividing by something, or our growth factor is going to be a fraction in between 0 and 1. What's our initial value? Our initial value is just our y-intercept, which is right here, right? So our initial value is 2. Then we want our growth factor. And in order to find our growth factor, the easiest thing for you to do is take 2 points from the graph and divide their y values. Now, when you do this, you always want to take the y value on the left and the y value on the right, and you're going to divide the right one by the left one. So like if I was traveling along this graph, if I was going this way, right, this point, I would hit this point before I ended up hitting this one. So I always want to do, like if I was labeling this y1 and y2, I always want to take the farther to the right point divided by the farther to the left point. So I always want to do y2 divided by y1. And I have to make sure I do that in order, because if I flipped it around, it's going to end up making it look like a growth rate of like an actual exponential growth function instead of exponential decay. So that's why it's also kind of helpful if we pick out that we knew it was decay, then I know I should be getting a fraction. And if I didn't, then I know I flipped the order that I divided those. So I look and I see y2 is just 2. y1 is 4. And I'm getting this right from the y values at those points. 2 over 4 simplifies to be 1/2. So my growth factor is 1/2. My initial value is 2. So if I'm writing my equation, I would say f of x equals my initial value times my growth rate to the x. So picking out your initial value, finding your growth factor, and then just plugging it in.
Wait, what if like you picked a different point?
So what if I used, like, what if I had done this as y1? I have to make sure that I pick the next one to be y2. If I didn't, then I'd have to make sure that I was actually, like, I'm intentionally picking things that are one space apart so that I'm dividing by 1. I want them only to be one space apart because I want to know what I'm multiplying by or what I'm dividing by to get from one point to the next. So I'm doing that on purpose. But even if I picked 2 different points, as long as they were one space apart, I'm still going to get the same thing, right? Because here I'm going to do 4 divided by 8 with the purple ones, and I'm still going to end up getting 1/2. So you can always double check yourself if you wanted to and pick a couple and make sure they're all the same. So then let's look at this one. So now, difference is that graph is starting off slow and increasing. So that tells me we're working with growth. It's going up. So that helps me know that when I find my growth factor, I should definitely be getting a number bigger than 1. If I'm not, then I probably switched the order of the points that I was dividing them. So I should go back and check. My initial value is 2 again, because that's where I crossed the y-axis. If I'm finding my growth, ooh, that's a scary G, growth factor, I'm going to call this one y1 and this one y2. I always like to deal with the smaller numbers just because it makes life a little bit easier. I wouldn't be wrong if I picked my point at x equals 1 and x equals 2. I'm just dealing with bigger numbers then. But so then if I take y2 is 6, y1 is 2, 6 divided by 2 gives me a growth factor of 3, which I know is good because I wanted a number bigger than 1. So then all I have to do is write my equation. F of x equals my initial value times my growth rate to the x. Not bad?
No, but it's gonna get worse.
We're going to look at tables. I personally like the tables better. I don't know, because you can see the pattern right away, because you see the numbers, instead of having to pick out the points and then find your growth factor, I think the tables just kind of make a little bit more sense, because as soon as you look at them, see, as soon as we go and look at the table, as soon as you look at that table, you can see your y values are 2, 4, 8, 16, 32. It's almost easier, I think, because you guys are so used to picking out patterns of things and recognizing that already, that you can see it before, and it just makes a little bit more sense, I think. So you're still going to do the same thing. We're first going to look, and we want to look at our y values and see, are they growing or are they decaying? Are they getting bigger? Would mean growth. If they're getting smaller, that would mean decay, right? So they're getting bigger. So we're definitely talking about growth. Then we still want to pick out our initial value. And our initial value is going to be our y value when x is 0, right? So our initial value is just right here, 2. Then we want to find our growth factor. And if you looked at this and you didn't right away say, oh, 2, 4, 8, 16, 32, I'm multiplying by 2, you could go in and say, okay, take my second y value, divide it by my first. So 4 divided by 2, and I get 2.
Maybe like a 1/3, like growth or decaying by 1/3. Can't you just put like -3?
No, because it would put 3 to the negative 1. Because multiplying by -3 is just going to switch the signs. Your numbers are still going to get bigger. So now all I have to do is go in and write my equation, right? I can say, okay, f of x has an initial value of 2 and a growth rate of 2 to the x. Could I make that 4 to the x power? Is it the same thing? No. Order of operations says I have to do exponents before I can do multiplication, right? So it is like highly, highly mathematically illegal for me to distribute that in there, because that second 2 is protected by the parentheses and that x. So I can't combine those and make that 4 to the x. It's not the same thing. So even though it's like in our simplifying genes to want to like put 2 and 2 together and make 4, you cannot simplify these. You should always have an initial value and a growth rate separate, because the growth rate is all raised to that exponential power, and you can't do multiplication before you do exponents. So you can't bring those together. That's a mistake I see people make sometimes. I just want to make sure you guys were paying attention to that. Hardest I can make it.
We all look at her like, this is a oh, wait, I see it.
Hardest I can make it.
1/3.
They times by, it's decaying.
Well, it's definitely decaying, right? It's getting smaller.
There's a 3 involved.
Somewhere there's a 3. What's the initial value? Oh, they didn't put it in the table, did they?
No.
But you've already told me that
7.9.
each time I'm dividing by 3, right? Dividing by 3. Dividing by 3. So if I know I'm dividing by 3, if I've got to go backwards, I just have to multiply by 3 to find out what's happening if I wanted to extend my table, right? And make a 0 column. If I do 243 times 3, what do I get? 729. So now I know my initial value is 729. My growth rate, or my growth factor, is what? 1/3, right? Because we're not going to write divided by 3 in there. But dividing by 3 is the same thing as multiplying by 1/3. If we weren't sure, we could do 243. We could do 81 divided by 243. And when we simplified that, we'd get 1/3. So our equation is going to be f of x equals 729 times 1/3 to the x. So that's as hard as it can get if they're not giving you the initial value and you've got to find it. So if they don't give you the initial value, I would find the growth factor first, so then you can use the growth factor to go back until you get to the initial value. Let's do it.